Okay, here we are. It is time. I am going to draw into this canvas a kitty cat. And then I'm going to have something show me here, tell me, is that a cat, or is that a rainbow, or is that a train? Now, before I can get to that, I want to first at least make this somewhat interactive, that I can train for an epoch just by pressing this button. I can press this button to run the test to see how many things I've got correct. So I did some things in between the last video and this video. I added the buttons here in HTML. I used my magical advanced CSS abilities to alter how those buttons appear. I am now officially a graphic designer. I have also, by the way, moved some of my code into separate JavaScript files. So the train epoch function and the test all function are in this JavaScript file, and I have this data prep JavaScript file just to kind of move things around. So the first thing that I want to do is I want to be able to attach events to those buttons. So I want to say train button equals select, and I'm using the P5 DOM function, train, and then I'm going to say train button dot mouse pressed, and I will, I'm just going to say, right, train epoch. So this will run the train epoch function once. And if you don't know about arrow notation, or then you can check out my video about that, but I'm trying to use it a bit more in cases like this. Test button, select test, and then I can say test button dot mouse pressed and do the same thing. Now here's the thing. I'm going to actually write this function out a little bit. So hold on a second. I want to use the arrow functions, but I really just refactor it later. Let's make this easier to read. Epoch. So, well, I'll write an anonymous function. That's okay. I can handle that. You can convert it in your head to an arrow function. I'm going to call train epoch. I'm going to have a variable called epoch counter, which is equal to 0. I'm going to say epoch counter plus plus, and then I'm just going to say create div. I'm just going to console log it. Console log, and I'm going to do exactly what I did here. But I'm going to say console log epoch counter. So every time I press that button, it's going to train for an epoch, increase the counter, and console log that. Then I'm going to do almost the same sort of thing with the test button. And test button, test all. And then I want to get the percentage correct. Test all, and I'm going to say percent is percent. And let me at least number format that. Number format percent, 2, 2, and then let me also add a percent sign. And one of these days, what's that thing you can do in ES6 now with the backticks? I'll get to that at some point. Okay, so this is what I'm doing. I now have a train button and a test button. Let's see. Let's see how this goes. I am going to train. Let me just test. Cannot read property length of undefined. Ah, right. So one goofy thing that I set up here is I've got to pass in the data that I'm using, which I'm sure I could refactor in a way which I don't need to do that, but 32%. Ooh, do I not have the 100 times in there? I thought in my train test, oh, let me multiply it by 100. So the percent, right, is 0.35, but I want to multiply it by 100, so I see 35%. 35.5%. So we can see test, 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 no matter what. Now I'm going to train. Unfortunately, this is all blocking. I would want to do something, and I could use ES6 and promises, or I could probably use set timeout. There are various ways that I could make this asynchronous so that the browser didn't freeze up while it's doing the training, but I trained for one epoch. I tested again, and I got 78%. So now at least we've got this interactive. I can kind of keep pressing train if I have the patience to do it and see if it improves a little bit, 80%. Now, here's the thing. Let's do something really exciting. What I'm going to do right now is I'm going to add a draw function. Actually, I'm not even going to add a draw function. I'm going to add a mouse dragged function, right? Whenever, I'm going to add a draw function. I'm going to add a draw function, and I'm going to say stroke weight 8, line p mouse x, p mouse y. So this is in P5, the previous mouse position. Then I'm going to add mouse x, mouse y, and then I'm going to see what that looks like. Oh, I don't see anything. Probably because I need to say I want what I'm drawing to be white. There we go. But now I want to only draw if I'm pressing down on the mouse. So I'm going to say if mouse is pressed. So now, if mouse is pressed, so I could draw my own cat. I'm going to work really hard on this. I don't have a way. So now all I need to do, right? All I need to do is grab the pixels of what I've just drawn and turn it into a 28 by 28 image that I sample down and normalize to 784 inputs, give it to the neural network, and have the neural network say, meow. So let's see if we can make that happen. Okay, so what do I do? Now I'm going to need another button. And I'm going to call this button guess. And now I'm going to say, I'm going to just grab all this code, and I'm going to say guess button equals select guess. And when I press the mouse on that button, what do I need to do? So the first thing I need to do is I need to somehow make an inputs array. That's all I need. I need an inputs array with a bunch of numbers between 0 and 1.0 according to the pixels of what I've drawn. What would be the best way to do this? I could just read the pixels, but it's 280 by 280. I think I can use copy. Or get. I got an idea. I think I can say let image equal get. So I think the get function in P5 just grabs all the pixels from the canvas and makes it into a P5 image object. So let's see what that does, if I'm right about that. Yep, I got an image that's 280 by 280. Now, what I can do is I can say image.resize to 2828. Let's take a look at that. Now I have an image that's 28 by 28. Now, let me load the pixels, and guess what? Guess what, everybody? We are just right back to where we were earlier. When we, instead of reading in those bytes and turning them into pixels, I now have pixels that I essentially want to turn into bytes. So what I'm going to do is write a nice little loop. I equals 0. I is less than image.pixels.length. And I'm going to do something a little goofy here. I'm going to say I plus equal 4. So here's the thing. This is, by definition, a grayscale image. Right? I can't put anything but black, white, or gray in between here. And so what I want to do, I'm thinking here, is that the red, the green, and the blue values of each pixel are all going to be the same. So I can actually just skip every 4 elements in that pixel array, because the pixel array is RGBA, RGBA, RGBA. So I should be able to look at just every 4th pixel, not every 4th pixel, every 4th element of the array, and say the brightness is that image.pixels index I, and then inputs. Now here's the thing that's a little bit awkward. I should be able to say I divided by 4. You know what I'm going to do? I prefer to say, remember that variable I had called length? Let me use that. That should be 784. Another way I could do it is just say I times 4, right? to skip ahead every 4 and then say inputs index I equals bright divided by 255. Now, let me just say console.log inputs. I just want to look at that. Am I getting an array that is 784 floating point numbers long with each value normalized between 0 and 1? Let's see. So let me just draw some stuff in here, hit guess, and there we go. Now, can I find, oh yeah, there we go. Look at this. So it is working. I mean, I could have made a mistake somewhere, but this seems about right. So, I could be more thoughtful about drawing in a softer way that mirrors the doodles a little bit more, and the thickness is really going to matter. So I'm going to have to figure it out. Now, I'm being asked in the chat, shouldn't it be the other way around, black on white? Well, here's the thing. In all of my previous videos, if I open up my processing sketch, and this is a sort of point of confusion. If you recall, this is going to take a little while to load, so I'm going to talk while it's loading. If you recall, when I did all this stuff previously, you did see a black pencil doodle on a white background, which is this. However, what I did the moment I wanted to draw the pixels was I reversed it. The data actually in the data set is the other way around. So, machine learning wise, I'm matching it correctly. What I might choose to do, just to make this a bit visually more appealing, is I might choose to, just to be consistent here, is let me go back to sketch. Where's my draw function? Where's that draw function? What just happened? Did I put that draw function in I put the draw function in train test. That was by accident. Let me move that back to sketch. I'm going to change the background to 255. And I'm going to change the stroke to 0. And then I'm going to do something weird, which is I'm actually say 255 minus bright. I'm going to reverse it when I turn it into the data. So I can actually look at it like this. I kind of, now in the canvas is white, but I have an idea. I'm going to say body. Can I say background color? And let's just make this some light gray. Look at me in my CSS. All right, I can see now, oh, beautiful. This is where I'm drawing my cat. So let's press guess, and we can see it's still a whole lot of zeros. So I think I'm good. I think things are looking good. Okay, now what I need to do is now let guess equal neural network dot predict those inputs. And remember, I did this in the testing. I then already figured out the code in the testing to get that classification, right? Remember this? I have to find the highest, in the outputs, I have to find the highest one and what index that is. And so now I am going to say maximum classification, and this is really goofy, but I'm just going to say if classification equals cat, this is the worst code anybody could ever write. But I'm just going to do it this way, just to get this done. And I'm going to let those of you watching create your own variation of this with an actual interface and be more thoughtful about how you end this up. I got one more. Train, console log train. Okay. Are we ready? Are you ready? Are we ready? I think we are. So here we go. So I'm going to draw what I think is a cat. Some whiskers, I don't know, and a little smiley, a little dot. Okay. Now I'm going to guess. What is that? It's a rainbow. Of course it's a rainbow. I haven't trained it yet. So I shouldn't, if I got the right answer, we'd have gotten just very, very lucky. Now I am going to run the training. Okay, it's training, it's thinking, it's going to train. For one, it would be nice to have an animation telling it doing it did for one. Let's just run the testing. it's getting the test data right 80% of the time. So even if, at best, this is going to fail 1 out of 20% of the time, which is quite often, if you remember recent events in our history. Here, okay, a guess. A train. Let's train it one more time. At least he didn't think it was a rainbow this time. Let's train for another epoch. Try to get a little more accuracy here. I think I normalized the data correctly. Let's run the tests again. 82%, let's guess. Train! So, my soundboard doesn't work. It's a train, everybody. And good night. Thank you very much. This is the end of this video. All right, all right. Well, let's go back and do that again. I mean, I'm very happy with it to fail, but at least now I have the sound effects. It'll be more entertaining. Okay. All right, I'm going to draw for myself a cat. You know what? I think this isn't thick enough. One thing I should do, let's take a look. One thing that I could do here, I want to see the resized image. So let's make this a little bit thicker when I'm drawing. I think that's going to help. Where am I drawing again? In the draw function. Let's make this 24. I think this is going to be, I don't know. I'd have to look back at the train again. No, I think it was actually fine. Let's just make it 16. Okay, that's a little bit better. So I'm going to try to make a cat. But actually, one thing that I want to do is when I press the guess button, I kind of want to see that resized image. Where is that? So let me also, let's just see if I can, I'm just going to draw it. Image guess 0, 0. I just want to be able to see it like, whoops, execute draw image on, oh, not the guess, image. Just want to see what it looks like. Yeah, that's the smaller version of it. I think that's okay. That kind of feels like what the doodles look like. So let's try. Okay, I'm going to draw a cat. I really should probably use the rainbow. Give it some nice whiskers. And now I'm going to guess. What is this? Now I haven't trained the neural network at all. So I just have like a 1 out of 3 chance of getting it right. It's a train. And look, there's my doodle sample down. Yeah, so that's not correct. But of course it shouldn't be correct. Now, let's train the neural network. And it's going to have to wait. We're going to train for a epoch here. We're training. Okay, we trained. Let's run the testing just to see. 75%. Okay, that's pretty good. Let's guess. It's still a train. I do want to point out though, whoa. What am I console logging here and why was it different? Something weird is going, oh, you know what? Because it's got all these pixels there now in the canvas. So that was a bad idea for me to draw that up there. That was sort of just for debugging. Let's try this again. Let's draw a rainbow. Rainbow might be more recognizable. Okay, so I'm going to draw my rainbow. Right, that's my rainbow. I'm going to guess. It always thinks it's a train. Let's run the test data set. It got 33% correct. Let's actually train the network. It's going to be not a rainbow, probably. It's very unlikely that this will work in any way. Oh, it finished. Okay, now here we go. I'm now going to guess again. I can't bear to look. All right, fine. Let's train it one more time. We need 2 epochs for it not to just always think it's a train. I'm kind of suspicious here that something might be going wrong because it always thinks it's a train. It's a conspiracy because it's the coding train. All right, we did 2 epochs. Let's run the test again. Hey, our accuracy went up from 33% to 80%. I really should get rid of these unnecessary console logs. And I'm going to guess again. Here we go. It's definitely going to just say train, isn't it? Oh, I hit train by accident. Oh, no. Epoch 3, test 81%. Okay, here we go now. Let's guess. Here we go. At least I got cat. I mean, we got to be happy that we got cat, right? Let's train again. I mean, 20% of the time it's going to be wrong, and most likely more than that. Now, is my data? Is the new data formatted exactly right? Okay, did another epoch. 81%. All right, I'm going to pause for a minute here and investigate to make sure there isn't anything horribly wrong. Because what could be wrong, I mean, I'm not surprised this isn't working, but if my data, the way that I'm passing it and formatting the data is not the way it was trained, then we've got an issue. Hold on, everyone. There's actually kind of a major problem right here. I was being all fancy refactoring it to use this map function, but that makes these inputs restricted to uint8 thingies, integers, only a 0 or 1. I really want to just divide by 255 and make them nice floating point numbers. So I could go back to my loop, or apparently I could say array from data.map. I believe this will create a new array, and let me just check that in the testing. I'm going to say console.log inputs, and let me run test, and now we can see, yes, this is a regular array with numbers that are somewhere in here. Oh, let me look in the middle, that are floating point numbers. Okay, this is good. This could be the source of a lot of our problems. So let me take this and put this also here. So that fixes it for the training. And now, oh, and by the way, while I was taking that break, I added a clear button. And let me just show you the code for that. Trying to figure out what was wrong. In sketch.js, there is now a clear button, and all that clear button does is draw the white background. So we are ready to attempt again. Let's try. I'm hopeful. Let's just see, by the way, what does it think an empty image is? It thinks it's a train. Because as we know, it's always a train. Maybe I should try drawing a train. Let me draw the rainbow. I feel like the rainbow's got to be the most recognizable. And by the way, I made the stroke a little bit thinner. And I don't know. Let's make this the rainbow. Okay, so now, first of all, I haven't trained it yet. Let's guess. It still thinks it's a train, obviously. Let's test. Oh, I forgot to have that console log. 31%. I want to get rid of that console log in train test. Let's get rid of that. So let me start over here for a second, and let me draw my rainbow. And let me guess. It is, of course, a train, as it always is. Let's run the test. We got 30% right because we're just guessing. Let's train for an epoch. Oh, it's finished. I get so involved with my dance. We got 85% correct. This is good. Let's now guess. It's a cat. Watch, look. It's got whiskers and a little ears, and it is totally a cat. It has guessed a cat. Let's clear, and let's try drawing a train. This is my train. It's got a big choo-choo thing. There's my train. Thank you. Thank you. This is the coding train. So there's so much that could be improved here. The real problem is that I am using a tiny data set. The other problem is I haven't been really so thoughtful about thinking about this spatially. I'm flattening this image into one vector of pixels. And where it's using a so-called convolutional layer in advance of this, what this is like final layer, is something that could actually help this to work much more accurately. I hope to come back to that in a future video. Also, probably adding softmax and cross entropy are going to be a way to sort of squeeze out a little bit more accuracy. But ultimately, what I would be curious for you to do if you're watching this, there's going to be more videos in this playlist, but this is, if you're watching this, you can, and they don't exist yet, what I would love for you to do is think about a way that you can try this with larger data. Try this with animation and think about ways to make this a bit more robust, make it more creative and goofy and fun, but we've got the basic idea here. So share with me what you make. All of the code for this will be published. There's so much more to do with it, but we've got a basic doodle classifier that mostly thinks things are trains. So thanks for watching the coding train. After this video ended, I went and tried a whole bunch of other drawings, and they worked. So right now you're going to see a quick montage of those moments where it worked. Let me draw a cat. Well, I'm hungry, I'm tired, it's been a long week, I'll be back next Friday. This is my cat. Ah! Hold on. Look at this. This is getting... I got a 1 out of 3 chance. Oh!